Okay. Welcome to ClojureScript. It's not just a language. My name is Christian Johansen. I work for Kodemaker, which is a consultancy here in town. And I'm going to be talking to you today about ClojureScript. And as the title indicates, this talk will primarily be about not the main language so much, but more the tooling around the language. So I've been working with web development for 15 years. I've worked extensively with JavaScript and the various libraries and frameworks that popped up along the way. And a few years ago, I started working with ClojureScript, and as of now, I've not jumped ship yet. So this has, so far in my career, been definitely the most fun and productive way I've found to develop web applications. And while the language is obviously a part of that, it really is the tooling that's been built up around by the community that seals the deal. And the idea of this talk is to try to sell you some of my enthusiasm for that tooling by showing you how it works. So, but before we get to the demos, we have to talk a little bit about the language so you guys know what it's about. So ClojureScript is a functional language that compiles to JavaScript and runs in the browser. It is also a Lisp, and Lisp is a family of languages, like they first emerged in the 1950s. And Lisps have a certain, some prejudice against them with parentheses and so on, and I'll get back to that in a moment. But the main characteristics of the ClojureScript language is, like I said, it's a functional language, and it has a suite of immutable data structures, and it has a huge standard library for working with immutable data structures, and most of that affords you lazy evaluation as well. So I'm going to show you just a few examples to get you started. So let's say I have a list of numbers. So that list being immutable means that whenever I perform an operation like adding something to the list or splitting it in two or whatever, that operation will always create a new collection. So as we can see here, can you read the text? Oh, it's too far to the left. Tell me. OK. Is that good? Even better. OK, so like you can see, I have a collection called numbers, and then I added the number 4, and I have a new collection, and hopefully my existing collection should still be the same. And it is, because it's immutable. So you can never really change inline values. You don't have mutable state, or you do have mutable state, but you have specific constructs to work with mutable state in ClojureScript. So this feature is the prime enabler of many of the other cool things that I'll show you eventually. Another example would be to create a sequence of a lot of numbers, like a million numbers like that. And then I'll create a function that can square a number. And just for demoing purposes, we're going to print which number is being squared. And then we're squaring that number. This is my function, and now I'm going to create some squared numbers by mapping over my 1 million numbers with this square function. And here's the trick. This is now being calculated lazily, so if I ask for the first 4 numbers of this collection, we will see that, squared map, squared numbers. Sorry. We'll try it once more. Now, if I ask for the first 4 numbers, I'll get back 0, 1, 4, 9, and then it prints out square 1, 0, 2, 3. So it's actually just performing the map on the items that we do actually need. It's not doing it a million times. And if I do that once more, we'll see that it's not going to recompute the values at all, because they're immutable. So there's no point in reevaluating the function. So that's the core features that I'll focus on for now. We also have to talk a little bit about parentheses, because there's this myth that Lisps have just huge amounts of parentheses. And for ClojureScript's sake, it's partly true, but it's also partly myth. And in the cases where it is true, it's actually an advantage. And I'll show you some examples. So the first thing that people notice is that when you have JavaScript, code looks like this. You call a function. If you do the same function call in ClojureScript, it's going to look like this. So the parentheses is all wacky placed on the left side. And this confuses people, but this doesn't really add parentheses, right? It just puts it in a weird place. Another case where ClojureScript usually does have more parentheses is in the case of arithmetic expressions. So in order for you to understand this expression the way that it's going to be evaluated, you have to know more than what it says on the paper, because there are precedence rules for operators, right? So you have to know which operator is being applied first. So this could turn out as 11 or 15, depends on how the engine understands your expression. In ClojureScript, you would just add parentheses to avoid this problem at all. So in this case, there are more parentheses, but it's an advantage because it's become more explicit. And ClojureScript doesn't have operator precedence rules at all. So it's just less stuff for you to know about, which in my book is a good thing. OK, here's a JavaScript function, and I'll show you the ClojureScript equivalent, and we'll compare them side by side. So which has the most parentheses? It turns out that they both have the same amount of parentheses. It's just that ClojureScript has more of the round kind, and JavaScript has more of the squiggly kind. But the more interesting aspect of this comparison is that the ClojureScript version does not really have a lot of syntax. So in JavaScript, you have syntax to create a function. You have syntax to do flow control. There's syntax to return values. In ClojureScript, you have basically none of that. So we're going to investigate the data types in ClojureScript to understand why that is. OK, so this is going to be a really quick race through a bunch of data structures in ClojureScript. I'm not intending for you guys to understand the language very deeply at this point. It's just trying to make a point about the syntax of the language. So ClojureScript has strings. Strings are JavaScript strings. You can call JavaScript methods on them. There's no layer in between. ClojureScript also has keywords, which are kind of like strings. You would use them in cases where you want to address things. So as keys in maps or objects, stuff like that. They can also have namespaces, as you see in the example here. We have numbers. They are JavaScript numbers. And then we have symbols, which in JavaScript, you probably know them as just variable names or function names. And that's also the role that they usually play in ClojureScript, but you can also process them as data, which is important. And then you have lists. So because lists are immutable, like any other piece of data in ClojureScript, they also have value semantics. So in JavaScript, you can compare a string to another string, and they will be the same if they have the same content. But if you take two arrays that are different object instances, they would not compare the same. In ClojureScript, they will. They have value semantics because of immutability. And this applies to all of the data structures in ClojureScript. So vectors are just a slightly different kind of list, which would be the one that you would use the most. Also has value semantics. Then we have maps. Maps are, you'll use maps in ClojureScript just like you use an object in JavaScript. And if you're the kind of developer that likes to discuss where to put the commas at the beginning or at the end, you will love ClojureScript because you can have as many commas as you want. ClojureScript treats commas as white space. So you can leave them out, or you can include them in if that helps you. In most cases, maps in ClojureScript will use keywords as keys. So the structure will look like this. Again, you have value semantics. So if you have two different maps with the same content, they will compare true. Then we have sets, which are lists of unique things. OK, cool. Let's get back to our function here. So again, we're looking at a function. And now that we've quickly seen all the data that ClojureScript supports, we can understand this piece of code in a different framing. Because the parentheses, those are the syntax literal for lists. The square bracket here is the syntax literal for vectors. This here is a map. So in fact, ClojureScript data is ClojureScript code, and ClojureScript code is ClojureScript data. So there's no particular syntax to the language other than that of its data structures. And this is a really elegant simplicity to it, which means that you're always working with data. And when you evaluate data as code, then the list form will be a function call. So in this case, defin defines a function in ClojureScript, but it's really just a special kind of function call. The same with if. If is really just a function call. And this is, gives Lisp its peculiar look and gives the rise to the parentheses myth. But really, it looks this way because it's uniquely simple and elegant at its core. So that's cool. I'm going to talk more about why it's good for the code to be data a little bit later in the presentation. OK. Now I'm going to show you the first tool, which is Figwheel, which is a tool that's developed for instant feedback as you develop code. And to do this, I have created a stupid little app to show you how it works. So let me just resize my window. Whoop, OK. So it's just an app that it shows animal faces. And there's a small icon that you can click. And you can choose to remove it or not. OK, so I clicked this button. It didn't really work. So there's a bug in the program. So we're going to fix the bug in the program. So usually when you work with web applications, you would then go to your code, find the bug. I'm not going to tell you all the details about this code. I'm just going to tell you that here it says delete. It should have said delete. So I fixed that. And then what you do, you go back to the browser, reload your app, and then now you have to retrace your steps, click all the buttons, and then figure, yes, OK, I solved the bug. But this is kind of tedious, right? Because the more complex your application becomes, the harder it will be for you to recreate the exact state that showed you the bug in the first place. And you're going to be clicking and scrolling and doing these things over and over again, and you lose your flow, right? Hopefully this is a familiar situation for you. So now I want to close this pop-up here by clicking somewhere, and that doesn't work either. So now I can do the same thing again, or we can try to do something better. So the reason why the code got updated in the first place is because I'm already running Figwheel, which is a library. But I'm not running it in its power mode. So let's fix that. I'll ask it to include a REPl, which is a read eval print loop. And I'll ask it to auto-load my code. And then I have to do something which takes a little bit of time. OK, reload config. So now Figwheel is going to dump all the compiled code and compile everything from scratch. And then I have 2 builds running, so this is going to take a little bit of time. But once it's done, we're not going to have to wait for pretty much anything at all. So I'll just find the file while we're waiting. So this takes about 20 seconds per build-ish. Cool. OK. So the idea now is that we're going to add to this section of the code. This is the data that's being added for rendering when you're watching the details. So we want to add a cancel action into this. So now I'm going to reload the app manually for one last time. And now I click here, here, now, and now I want this to work. Clicking here should close this thing. So I can then go in here and add a cancel action. Again, the details of this isn't really all that important. Pictures, basically I'm going to remove the show details flag from this particular picture. So when I do this, Figwheel is hopefully going to recompile my code. And it should have reloaded the browser, which it didn't, so that's interesting. OK, so now it works. Something's amiss. OK. Now you can see that every time I save the file, the browser gets updated and it's reloaded for me. So this is one step better. Now I don't have to press the reload button anymore, but I still lose my context. So if I go in here, click this one, click here, and then change my code, then Figwheel is going to reload the browser, and I still lost the current state of my application. So this is not really much of an improvement at this point. In order to fix that last step, my code has to be reloadable, which means that when ClojureScript, the process recompiles this file and places it into the browser again, it cannot override pre-existing global state. because if it does, then I lose the state of the application and I'm back to scratch. So ClojureScript makes it really easy to solve this problem because it has immutable data and it has specific tooling to manage mutable state, which is the core of the problem. And in the case of this application, I have only one piece of immutable state, which is defined here. It's called store at this line. And then every time this file is being updated, it's being loaded into the browser, and it's just recreating the initial state. If I change the def to a def once, that's no longer going to happen. That's going to create the state one time. I can manipulate it over time, and then when the code is reloaded, it's not going to overwrite that global variable. So the other piece of the puzzle that makes this work is that this is being rendered by React. And React has a diff mode for updating the UI. You give it some data, it performs a diff with the previous version, and then it updates the DOM. It doesn't have to be React, but that model of updating your UI certainly does help. So with this in place, I can now go and change, let's say I can go in here, look at the details, then find a details component and add some text to it just to see if it pops up. Hello, NDC. So I save that file, and now the text just pops up in the current state of the application. And this is very, very useful when you're developing complex applications. You have lots of drop-down menus, and you can click and drag and scroll all over the place, and you never lose your place. So this is very cool for the code, obviously. It's also used for CSS. You can see that many of my components are using inline styles here, but some are not. So if you can see the eye in the corner of the image here, if I wanted to change that, I could find the CSS file that this application uses. And then there's a button down here. So I want to add a transition to the button for the background, give it a little bit of a swoosh effect. And then on hover, I'll change the background to black. Just save it, and then when I hover now, it has a nice effect, or not, because I'm not a designer, but it has an effect anyway. So yeah, you never need to lose your place again. You can just keep your context. Very, very, very useful. This is, of course, possible in other languages as well, but the immutable data that ClojureScript provides you with makes this really simple to do. OK, but maybe this is just one browser. Let's say that I'll add a phone into the picture. And oh, now I can see that the pictures are actually too wide to fit on the iPhone. So if I get into my core file, there should be, OK. So here it says that the width should be 500 pixels. Actually, that's too wide for an iPhone, so I want to set max width instead. There we go. I save that, and then things should look fine on the iPhone as well. Cool. And then my app works great here as well. Yes. You can use the console to do fig status, which tells you something about the status of your system. So now I have two connections to the dev build, which is the iPhone and the Chrome. And then I have a test connection here, which I'll show you in a minute. So if you see my browser there on the tab to the left here, there's a green square. And that is a tab that Figwheel is also running, which is running tests. This is really tiny, but it's not really all that important. So this is not very useful test output, but the favicon on the top here is quite useful. So let's say that I unfix my bug from before. Then this tab is going to turn red. So I just keep this up just for a small visual clue of what the state of my tests are in. For actual test feedback and for CI servers and whatnot, you can run the tests in a console like you would in other languages. So the details, again, not all that important, but the visual clue here is really nice. There's one more feature which is quite useful. So sometimes, not all the time, but occasionally I make mistakes when I write my code. And perhaps I misspell a variable name like this. And if I do that, the code's not going to work correctly. So Figwheel tells me that with really tiny font. It says that it points out the exact place where there was a warning. And then it does one more thing, and that is that it does not reload the code, because reloading the code at this point would break the application. So instead, it just prompts me that there's a problem here, you should fix it, and when you fix it, I'm going to reload the code for you. Same thing happens if you have a compilation error, which you can do if you have unbalanced expressions or whatever. Same thing, it's just that the box gets ominously red. The box gets ominously red, and the error message will sometimes be less helpful. Yes. Cool. So that is the basics of Figwheel. You can see that the info that I got up earlier is still up. And yeah, very, very useful. I'm going to show you more Figwheel a little bit later. OK, so when you have a compiled to JavaScript language, like ClojureScript is, then you don't really want to recreate the entire world in its image. Like the JavaScript community has vast amounts of tooling and libraries and all kinds of stuff, and having to recreate it all in ClojureScript would be quite a loss. So ClojureScript provides excellent interop with the JavaScript runtime and also the library ecosystem around it. So just a few examples. I'm going to fix my window again. OK. So the slash is ClojureScript's way of denoting namespaces, and the JS namespace gives you access to all the JavaScript globals. So JS/window is the window object. If you want to access properties on JavaScript objects, you can do that via this syntax, --location. This is the window location, or you can use the more familiar look of this. So if I evaluate this, it shows me the location. Getting properties, nice and easy. If you want to call methods on JavaScript objects, which you do sometimes, you do it like this. So this mimics what Lisp usually looks like. You have the function first. So in the case of object methods, you have the function name and then the object, and then you have other parameters if you need them. So here's an example of slicing a string. And this is just a different way of writing JavaScript, right? So this is useful when you're using the browser APIs, or if you're using libraries like D3, that would be a bit of a chore to rewrite the entire thing in ClojureScript. And you can just use those things, and there's excellent syntax support for doing so. You can even use node modules. So in your compiler configuration, you can now say install deps true, and then you can list NPM deps that you need for your application in case you need to interop with, for instance, D3 or other JavaScript libraries you want to use. And then when you use the ClojureScript build tool, it's going to install the NPM dependencies in the background for you and create a package.json and manage that for you. And then in your namespaces, I can require clojure.set from the standard library, clojure.string from the standard library, and this library, which actually comes from node modules. So this is a fairly recent addition to the ClojureScript compiler, but it has been really, really useful. You can even do like this and import individual files from the modules that you pull in, like you would with require, for those of you who have used JavaScript before. I'm just assuming that you have at least passing knowledge of JavaScript. Otherwise, this makes no sense. OK, let's revisit those parentheses. I'm going to get back to one more example of interactive development, but first we got to take a look at the parentheses. So ParEdit is an editing mode that originally came with Emacs, but is now available for IntelliJ and a bunch of other editors. And it's a different way of editing code than you're used to. So instead of destructively changing the source code of your program character by character, ParEdit relies on the fact that Lisp code is data. And then it allows you to manipulate those data structurally instead of just wiping out characters nilly-willy. And this is it's quite different way of writing code than you're probably used to. So in the beginning, it's really painful. And when you learn how to use it, then going back to the old way is extremely painful. So I'm going to show you how it works. But first, we have to see a famous quote about ParEdit. So my friend Magnar Sveen once came into the IRC channel for Clojure, and he said that I've tried ParEdit, it's not really for me. And the response that he got was, if you think ParEdit is not for you, then you need to become the kind of person ParEdit is for. And this is very true. Initially, you're going to think that this is not for me, but you just have to change the definition of me, and it's going to fit perfectly. So, excellent. OK, very basically with ParEdit, it makes sure that things that need to stay balanced are balanced. So in a ClojureScript program, a single double quote has no meaning. So whenever you insert a double quote, it inserts 2 for you. So you can write a string. If you want a double quote inside your string, you can get 1, and it's going to get escaped. If you try to delete the final double quote, it's not going to let you, because that would screw your program. So you can go all the way back here, and when the string is empty, you can remove the whole thing. Perfect. This will be extremely annoying in the beginning, but when you're used to it, it's very, very useful. So everything that comes in pairs get inserted in pairs. So lists, there's no reason at all to have a single left parentheses in a ClojureScript program, so you'll always want to have 2 of them. With a vector, same thing. And yeah, squiggly, brackets, and all those things get paired up very nicely. So then we have 3 other functions called kill, slurp, and barf. So Emacs has interesting terminology. Kill in Emacs is that's the name they gave to just removing text. That's called kill. It's very aggressive. So for instance, if I have a long line here, I can hit Control K to kill to end of line. Just removes the rest of the line. When you do this inside a Lisp expression, like let's say that this function no longer needs arguments, and I hit Control K here, it's going to remove the rest of the expression it's inside of. So it has knowledge about the structure wherein the code lives. And this is perfect, because doing this would not be useful for me, because now I have an unbalanced program. It won't even compile. So there's no need for my editor to support that. Well, it can, because I can select text and cut it, but that would be making things hard for yourself. Similarly, it has a function called barf. So I have a vector here with 5 characters in it. Let's say I don't need the last one anymore. I can barf it out. Bloop, bloop, bloop. Out they go. And then I can kill these 2, and I can slurp them back in. And now I've removed the 2 first arguments. This example is quite contrived. I'll write some code later, and then you can see me using it in action. But one relevant example of this would be, let's say you have something printing to the screen. Hello, world. And then I figure out, I only want to print this if it's midnight. So I'm going to add an if statement that looks like this, and then I can slurp the expression right in. And this allows you to, like I said, manipulate the structure of your code as pieces of data instead of just wiping and placing. And you'll also notice that there's no need for me to manually re-indent or anything like that. It just keeps it positioned exactly where it needs to go. It's very good. OK, next function is called raise. So here I have an if, and the if can only have 2 forms in it. The first will be the if clause, and the second will be the then clause, or else clause. Now, I have 2 expressions that I want to run in my if clause, so I put it in a do. And the do simply allows me to group multiple expressions as one. So let's say that I figure out that I don't really want to print here anymore. So now I only have 1 expression inside the do. And then I don't really need the do. So then I can raise this expression, and it will take the place of its parent expression. So similar, I could have figured out just here that I don't want to print anymore, so I'll just have one expression, so I'll just raise this one up. And it takes the place of its parent expression. Quite useful. Here's a similar one. Raise is perfect for lifting one expression to one level up. If you want to lift both of these expressions up, then you have to use this weirdly named function here. I'm not going to try to pronounce it. But let's say that I figure out that I don't want to have my conditional anymore. Everyone's going to eat ants from now. So I'm going to start by erasing the do to take place of the if. And then inside the function body, I don't need the do. So now I can do splice sexp killing backwards to remove it. And then I'm left with only these two expressions. So it looks strange when it's new, but I promise you when it's in your fingers, manually editing code character by character feels extremely clumsy. This is Emacs. Yes, but the same editing mode is also available for Vim and IntelliJ and most other popular editors, usually as an add-on that you install. Yes, final example. Here I have an if, and inside the if is a let. So the let defines the local variable settings. And it turns out that this expression is being used twice. So it would be cool to move the if inside the let, so I could use the variable instead of looking up the value twice. And to do this, I can use convolute s expression, which is the very aptly name, which does this. So it switches the place of the let and the if, and it also inlined the variable that I had here. Like from before, it was this is a map lookup, and then I convoluted it, and boom, it's now using the variable. This one I don't get to use as often as I would like, but whenever I see a possibility to use this feature, I feel like a god. It's highly recommended. So that is ParEdit. Looks a little bit strange, but it plays in with the language very, very nicely, and it really feels like power editing. One thing I did not show you is that you can also use ParEdit to navigate your code. So I can go to the end of the expression, to the beginning of this expression. I can go down into the expression and move in this level and down one more time. And you have this really neat way of navigating the structure of your code. So you don't have to use your arrow keys as much to flick around or, God forbid, the mouse to select stuff. OK. Back to our face application. So I'm going to drag my window. So when we introduced Figwheel into this application, I was able to keep the state and then work on local permutations of the application. But there are some kinds of feedback that are hard to, some kind of features that are hard to iterate on, even with that kind of feedback. And an example would be like if I remove this monkey, you see there's a really quick animation. If I wanted to study like the details of that animation and tweak it, then Figwheel doesn't really help me with that because the animation still passes along in 250 milliseconds, and my brain is not able to work that quickly. So we're going to look at another tool, or actually a companion tool called DevCards, which solves this problem. Yes. So I will get back to my. OK, so we're going to start another build called DevCards. And then I'm going to open a new tab called Cards. And again, the initial compile, when you start a new build, takes a little bit of time. But the idea behind this tool is to take a component, if you have like a React component or any component technology, and then you can display all the different permutations of the component on a single page. So in this app, I have a button that you saw before. I'm just going to find the code. That's colors. Here is my button. So now I want to display the button on a page of its own, so I can just look at the intricacies of the button, if you will. So to render the button, I simply call the button component and pass in the text. Click me. And to render this in DevCards, I'm going to call DevCard, and I call it basic button. Slurp it in, and then I save the file. It gets compiled, and then I can go in here. So now I have, this is a DevCard for the button component. It lists one button. Excellent. You can add some documentation here. The button is a clickable UI component. Very useful. And then you can also include markup in here, so you can use this as a way of documenting your UI components. Living documentation. You can look this over. Yes, it has quotes. Okay, so yeah, so you can use this as like living documentation of your components, and then you can add more cards like this for the same component. So now I'll call create a colored button. So it takes a color like so, and then when we have the colored button, I can have a disabled button, disabled $true. And now I can just lay out all the permutations of the single component on one page. And this increases my bandwidth of feedback, right? I can see multiple states at once. Red button, so here we go. OK, this component, though, is not very exciting because it doesn't really have a lot of interesting states. But here you can see. Let's try to develop a little bit more interesting component that we can view in this view. So I'll try to create a progress bar. So here I have a simple dev card that it has a progress bar with progress 0. And then I'll add another one with which have some percent, 25, for instance. And then we're going to have to actually create the component. So it's just 2 styles for now, or 2 spans for now. Let's add some styles here. We'll make it position relative. We'll make it background dark, like that. Height should be maybe 8 pixels. I can save it underway to see what it looks like. Right now, it doesn't look very nice. Let's add some text back here. Hello. Hey, yeah. OK. Width should be probably 100% for this one. Or actually, let's make it display block. And you have the same interactive feedback that it did with Figwheel. It's still Figwheel running, but in a different view of the application. OK, cool. Border radius, we'll add a couple more features to this, and then we'll take a look at it. This one will have background something light to overlay it. Then we'll be absolutely positioned. 1 pixel from the top, 1 pixel from the left. The height will be 4. And then finally, the width will be the progress, and then with the percent marker after it. So let's see what that looks like. OK, it's not tall enough. And let's just make it a little bit bigger so you guys can see. So I'll make it 18 and 16. Make huge progress bars. OK, I can see there's some glitch over on the edge here because I'm missing the border radius. Yeah. Anyway, my point here really is just to show you that what this kind of instant feedback allows us to do with our code. It's very useful. Now, I'm going to do one more thing with this component, and that is that I would like for this to progress like smoothly. If I tell it to increase the progress, I want it to move smoothly along. So to do that, we're going to have a transition on, I guess, this component, on the width. And then in order to watch that live, I need the progress to change. So DevCards has a feature for this. So we'll create a DevCard interactive progress bar. And then if you pass in a function, then DevCards is going to create a piece of mutable state and pass it to you. So I can render the progress bar using that data, and then I have to do something weird to it. And then you can provide some initial data. Progress 0. Let's just make sure it works. Okay, so I have an empty progress bar. And now I need to provide some way to increase this value. And we can do that with just some elements here. This is just React HTML virtual DOM elements. I'll create an A that has an onClick. There will be a function, and that is going to do swap, which is how you update mutable state in this particular case. And then we're going to do update progress p, and then if the progress is 100, we're going to go back down to 0. Otherwise, we'll just increase the progress with 5. Cool. Then we need some text for the button. I'm going fast now because the details are not all that important. Increase progress. And then I know that we're going to need to have some margins. OK. Now we should get a button. And when I click it, it's going to... so now I can really contemplate the details of my wonderful animation. But for some kinds of components, being able to just control it very finely like this is very useful. Now I can see that when it reaches 100, it actually goes 2 pixels over the edge there. So that's an edge case I would have to figure out. Like you wouldn't be able to catch this when it just swooshes on the screen. So because ClojureScript has such fantastic tools to manage mutable state, DevCards can do one more thing for you. So we can do inspect data here. And then when we do that, it's going to tell me the current state of the... so if you have, this could be a huge map with lots of data for a complex component, and it will tell you the entire state of the component. What we can also do is to ask you to add some history. And then when I hit this button, this other line shows up here, and I can step back to the previous version. Like this was really interesting. OK, 1 forward, and then get back to the current version. So this is a very, very useful tool to develop individual components like this. And just to drive home that point, I'm going to show you one from my daily work, which is on this. This is a mobile application for home automation stuff. So this is my living room. You have some components here. You can set the temperature. You can create a schedule for when the temperature should do what. And then this entire application is built from individual components that we have these kinds of cards for. So the buttons, for instance, these are all our buttons. Some of them have spinners on them, blah, blah, blah. We had the components that I showed you. The resizable areas are here, where you can just try them out. This shows the coloring of the temperature. And you can just... I worked on this today. It's not done yet. Yes. And also, in this application, very cool. I did not make the thing that I'm going to show you now, but whenever you go between pages, it has this really nice mobile application swooshy effect. And we have cards for that as well. So let's go back here and page stack. So here's the app with one page rendered. And then when you click to have a new page added, it's getting rendered on the outside. And then it slides over into the frame while the old page slides just a little bit out, which gives this really cool skeuomorphic effect. And in this case, I can actually step through the animation. So this is what happens to the entire page when you navigate in the app. And I think developing a feature like that without something like this is very frustrating, to say the least of it. And this tool is not very advanced, but it relies on the environment that ClojureScript creates with its focus on immutable data, and this library that I'm using that is using React under the hood, which is not allowing me to use component local state, which would make it harder to make this work. So I have one final example for you, which is an old game that I did some time ago. This is just a browser-based Minesweeper that I wrote in ClojureScript. So with Figwheel, you also get a REPl. And a REPl is, like I said, a read, eval, print loop. And this is connected to the browser. So we can see that by, I can interrupt with JavaScript and say console log, hello. And then it gets compiled, sent to the browser, and it prints hello in the console here, which is OK. But it's also connected to the actual state of the application. So if I get into the namespace sweeper.ui, I think, it's going to switch into that namespace, and then I can look at app data, I hope. That's not what it's called at all. It's called app state, I guess. No, that was not good. Let's see if we can find the file, and then we'll figure it out. It's called app data here. OK. Dref app data. Come on. OK, here we go. So this is the entire data structure that's being rendered right now. And to the bottom, you can see that it says dead true, because I screwed it up and hit the bomb in my game. So this namespace also has a function to undo that move, even though there's no UI for it yet. So I can even call that function, and I can control the state of the application from the REPl. And this is just hugely powerful, because now I can, in my editor, interface with the state of the running application in the browser. I can see the current state of the data. I can manipulate the current state of the data. And I can run individual functions. I can develop half a function, inject it into the game, click around, and go back and forth. And this level of interactivity I've never found in any other development environment. And it's really, really awesome. And I really suggest you check it out, even though the language has a few parentheses and looks a little bit strange. So that was really what I had. There's a bunch of other cool things that I don't have time to show you today. I'll just mention them in passing. The community is very good for ClojureScript. If you count like stars on GitHub and questions on Stack Overflow and the other useless kinds of metrics, it's not as big as other communities, but it's very positive. They have a Slack channel. Everyone gets their beginner questions answered. People are very friendly, helpful. And very important for me is as I get older, I get more and more tired of having to patch libraries and fix like deprecation warnings and crap like that. And the ClojureScript community has been very good at just keeping backwards compatibility a main objective. So I can find like this Minesweeper application. I wrote it 3 years ago. I pulled it up a few days ago, and it just compiles and runs. I have a JavaScript version of the same thing. Can't even install the dependencies. So that has lots of value to me. Like things are stable, and it's just things keep working. They don't stop working for no reason at all. So community is very good. There's a very interesting library called ClojureSpec, which would require a whole talk of its own. It allows you to do declarative data validations. And you can use it both in your application data and on your code, because your code is data, right? So you could use it in place of React prop types for validating props to your components. And you can even use it like as a light typing mechanism. You can add it to your function arguments, return values, and so on and so forth. Very, very cool. Datascript. There's a full-featured relational database you can run in your client-side applications. It has a query engine. It's amazing. I've worked with it multiple times. So I'm just throwing these things out and expecting you guys to go home and Google it. Core async, it's a library, again, for asynchronous programming in ClojureScript, which uses macros a lot, which kind of alters how the code is being executed. It's hard to describe very quickly, so I'm just going to leave it for you guys to Google it. It's cool. So summary, I don't have much of a summary. It's just that this stuff is cool. I hope that you think it looks cool as well and want to check it out. Like I mentioned, I work for CoolTheMarket, and we're looking for people to work with us. So if you want to work with me on cool stuff like this, you should talk to me. And yeah, that was it. Thank you for your time.